Okay, so we're going to continue with section 11.9's homework. We got to number 6, part A, and we were drawing the normal curve. So we finished drawing the normal curve and we've labeled all of our standard deviations. So now part B says, what is the probability that the part will not be between, or fail between 55,000 and 65,000 miles? So this one is a little bit confusing because it's asking where it will not fail. And in the original problem it says that it does fail, which is our normal distribution that we're given. So 55 and 65,000 is this area here in the middle, within one standard deviation. And remember we said that 68% of our data is within that area. So what we're going to do is we want to know the percent of everywhere else. So we know that all of our data is 100%, or 1 was our area under the curve. So we're going to take that 1 and we're going to subtract the 0.68, which is our 68% in the middle here. And that's going to give us this remaining area, or this remaining percentage. And that's going to give us a remaining 0.32. So there's 32% remaining. So there's a 32% chance that this part will not fail between 55 and 65,000 miles. On the next page, the last page, number 7. It says that a college only accepts students who score in the top 16% on an entrance exam. The exam scores are normally distributed with a mean of 25 and a standard deviation of 3.8. To the nearest whole number, what is the least score you can earn and still be accepted to the college? So we have to figure out where on our curve the top 16% is. And if we look at our curve, we know that we have 34% here, but we want the top 16. So we're looking at the right-hand side. We want to find where the top 16% is. So we can take the 50 and subtract the 34. And when we take 50 and subtract 34, so we have 0.5 minus 0.34. That's going to give us 0.16, which equals 16%. So our top 16% is past our first deviation. So we need to know the score. So we're going to take our 25, and to get to that first standard deviation, we're going to add 3.8, which is our standard deviation that we were given in the problem. That'll take us to that first deviation. So this is going to be 28.8. Now in the question it asks for the nearest whole number. So we're going to round this number, and we're going to round it up because this is greater than 5, and we're going to get 29. So the lowest score that someone can get and still get accepted to this college is a 29. For 8 through 11, we're given a normal distribution has a mean of 50 and a standard deviation of 6. So a mean of 50, standard deviation of 6. We need to find the probability that the value selected at random is in each of the given intervals. So the first thing that we want to do is find our standard deviations. So we're going to take 50 and we'll find the right hand side first, so we'll add 6. So that gives us 56. If we take 56 and add 6 again, that'll give us our second deviation. So we'll just go 2 deviations in each direction. And then 50 minus 6 will give us our first left hand, is a 44. And then 44 minus 6 again gives us a 38. So if we were looking at our graph, you would have your mean at 50, our first deviation, our second deviation on each side. We would have 38, 44, our mean, 56, and 62. So that's where our numbers would lie on our curve. So we want to know for number 8, from 44 to 50. So from one standard deviation to the left to our median, or our mean, sorry. So one deviation to our mean. That percentage, when we look at our curve, was the 34%, so 0.3413. So that's 34.13%. So 34.13% of our data lies right there in that section. For number 9, it asks from 38 to 56. So from 38 to 56. So that's 2 deviations to the left and 1 to the right. So in between here, we had 0.1359. From 44 to 50 is 0.3413. And then from 50 to 56, again, is 0.3413. So we'll add those up. You should get 0.8185. And that translates to 81.85%. And that was just adding these 3 sections on your curve. Number 10 wants at least 50. So your answer is 50 or above. It has to be at least 50. So it could be greater than 50. When we write this, this could be x greater than or equal to 50. So all these data values that are greater than 50. 50 was our mean, so we know that 50% of our information is to the right. So this is going to be simply 50%. Then we need to find number 11. It says at most 56. And that tells us that we're looking for x values that are less than or equal to 56. So those are going to be values to the left of 56. So again, we know that we have 50% of our data on the left hand of the mean, and then we have to add to get to the 56. So we're going to take 0.5 and we're going to add that 0.3413, that 34% extra. So we have 50% of our data to the left, and we're adding that extra 34%. So we're going to get 0.8413, which gives us 84.13%. And then finally, 12 and 13. For number 12, we're told that a local bakery makes chocolate chip cookies. The number of chocolate chips in the cookies is approximately normally distributed, with a mean of 11.4 and standard deviation of 1.3. What percent of the cookies have between 8.8 and 14 chocolate chips? So again, we're going to find some of our standard deviations. So our mean is 11.4, our standard deviation is 1.3. So we're going to take 11.4, and we'll find our right-hand side deviations first. So we'll plus 1.3. That gives us 12.7. Take 12.7 and add 1.3 again, and that gives us 14. So that's 2 deviations to the right. Now we'll take 11.4 and subtract 1.3, and that'll give us 10.1. And then we'll take 10.1 and subtract 1.3 again, and that'll give us 8.8. So that's 2 standard deviations that we just found. So if we were looking at our data, we would have 11.4, we would have 12.7 and 14, and then we would have 10.1 and 8.8. So we need to find the percent of cookies that have between 8.8 and 14 chocolate chips. So that's finding the area underneath these 2 full standard deviations. And the quick way to do that is remembering that included in 2 full standard deviations is 95% of our data. However, we also can add the percentages. So we would have 0.1359 plus 0.3413 plus 0.3413 plus 0.1359. That gives us the area here, here, and here. So we have those 4 values. When we add those up, we get 0.9544, which is 95.44%. So you can either do it adding the sections or just remembering that within 2 standard deviations, 95% of our data is contained there. And then finally, number 13. It says that the bakery described in exercise 12 sold 200 chocolate chip cookies. How many of the cookies had less than 8.8 chocolate chips? So we said that 8.8 was our second deviation on the left. So we want to know the ones that had less than 8.8. So that's the rest of the information that's to the left. So what we're going to do is we're going to take 0.5 and we're going to subtract the first deviation area and the second deviation percentage. So that's the 0.1359 is the percentage in this section, plus 0.3413 is the percentage in this section. When we subtract those, we get 0.0228, which gives us 2.28%. And we want to know what 2.28% of 200 is, because it wants to know out of those 200 cookies. So we're going to take 200 and multiply by 0.0228. That's going to give us 4.56. And this one we're going to run around because they didn't sell half of a cookie. So we need to round this, and we're going to round up because this is 5. So this is actually 5 cookies. So 5 of the 200 cookies sold had less than 8.8 chocolate chips. And that completes 11.9.